Hi and welcome Year 10s. Carrying on with filling in some of the gaps that we found in your work during the tests and exams. And one of those topics was simultaneous equations. Now, not just any ordinary simultaneous equations, but simultaneous equations that had an x squared in one of the equations. So that's what I want to focus on today, and I'm kind of hoping that as I go through this video you have your exercise books open and that you're going to work with me. We are working through two exercises today, and I'm going to do some of the questions that are set for you in the exercise. So I think it would be really helpful for you to work along with me. So the exercises we're looking at are 10.2 and 10.3. This is 10.2. So 10.2 and 3. Now let's look at part B, 1b. And you can see we've got two different equations here. They're in terms of y. So it's nice and easy. We've got y equals 3 minus x. And we've also got y equals x squared minus 3. So I can just make these two equal to each other because they both equal y. Now what I want to do next is bring everything across to the x squared side. So on the left hand side I'll have 0. And I bring the negative x across by adding it. So I'll get x squared plus x. Now when I get rid of this I have to subtract it. Okay? So I subtract 3 from the other side and I will get minus 3 minus 3, which is minus 6. And then maybe I can factorize. And I think I can. So factors of minus 6 that add to 1. And I'm thinking positive 3 and negative 2. Positive 3 and negative 2. So that gives us two values of x. Now see if you can write the two values that x must equal for this equation to equal to 0. So what do they equal? X equals minus 3, since minus 3 plus 3 in the first bracket would give us a 0, and 0 times anything of course is 0. In the second bracket we've got 2. So those are our two values of x. And now we can plug in those two values of y. And I would plug it into the first equation because it's the easiest. 3 minus minus 3 is 0. And 3 minus 2 is 1. So our two solutions are minus 3, 0. And the other one is 2, 1. What this actually means, if we were to draw this, okay, we've got x squared minus 3, which looks like this, doesn't it? And then we've got the equation here, a line equation, and it's got a negative gradient. It starts at 3, and it goes like this. So what this says is this would be 2, 1, and this one, well, obviously I haven't drawn this correctly, because this one should be negative 3, 0. But you get the idea of what's going on here. Okay. Alright, we'll do E now. For E, what have we got? Okay. Okay, once again, it's nice and handy because we've got both y's on one side, so we can just make the other sides equal to each other. So I'm going to write 3x minus 7 is equal to 2x squared minus 5x plus 1. I'll bring everything across to the right hand side. So I've got 2x squared. Now minus 5x minus 3x should be minus 8x. And that 1, I'm going to add 7 to it to get rid of the 7 from the other side. So it should be 8. Now you can factorize this, but if you are unable to factorize, don't forget that there is the quadratic equation that you can use. Remember, I'll write it down for you. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. You could use that, okay? And if you type that into your calculator, you'll get the two values of x. should you need to. But we can actually factorize this one, can't we? So what are we going to get for this? It looks to me like it's just 2x minus 4, hang on, no, minus 2. Oh no, sorry. What a Larry. I'm just looking at this again. We can actually just divide the whole thing. You could do that, or you could just divide everything by 2, and you get this. Okay, and when we go to factorize that, so I've just, sorry if I didn't speak clearly there. I'm dividing everything by 2, so 2x divided by 2 is x squared, minus 8x divided by 2 is minus 4x, 8 divided by 2 is 4. Okay, and so I think we are just going to get x minus 2, x minus 2. And you'll notice here that the value for x is equal to 2. There's only one value, and therefore y is equal to, and we'll just chuck that, I would chuck it into the first equation, 3x, so that's 3 times 2, 6, minus 7 is negative 1. Okay, so I'm going to plug in those two equations, 3x minus 7, so 3x minus 7, and then the other one is 2x squared, whoops, don't put it there, put on a new one, 2x squared minus 5x, and it was plus 1. Okay, and what you'll notice, and that's what we found, is that there's only one place where they're equal, it's this point here, 2 comma negative 1. So when you only get one answer, it means that the line, in this case, our line is this 3x minus 1. It means that the line is a tangent to the curve, right? And you can see that that red line there is a tangent to the curve. Okay, moving right along. So with this next one, whoops, it's a little bit more complex. So what I'm going to do is I'm going to make this first equation, I'm going to rewrite it so that it's x equals to 6 minus 2y. And then I am going to square that, so I get x squared is equal to 6 minus 2y all squared. And now what I can do is I can replace the x squared into here, and I can replace the x into there. So let's see if we can do that now. So x squared is 6 minus 2y all squared. We've already got the y squared, plus 4, and then x is 6 minus 2y, right? So this bit here is that bit there, okay? And then we're going to have y again, and is equal to 24. So now I've got to do some expansion. So I get 36 minus 12y minus 12y, so minus 24y plus 4y squared plus y squared. So I'm up to here now. If you're a bit hazy with expanding these kinds of brackets, you probably want to do a bit of practice, but trust me, I've done that correctly. Well, I'm pretty sure I've done it correctly. And then I'm going to have plus 24 minus 8y. Ooh, I haven't done 24. Plus 24 minus 8y, and then that's times by y. Right, you can see that. So I've just expanded like that. Now I could actually go one step further and just times all of that by y. So what we'll get there is 24y minus 8y squared equals to 24 on the other side. Okay, let's gather all of our like terms here. So I think I'm going to get negative 3y squared, right? 4, 5, take away 8, okay? Then we add our y's together. Well, looks to me like there are none. And then I've got plus 36 equals 24. And then I can get the negative 3y squared. I'll leave that there. I'll bring across the old 36, so that gives me negative 12, I think. So I should get y squared is equal to negative 12 divided by negative 3 is 4. So y should be equal to the square root of 4, which is plus or minus 2. And now that we know what that is, we can go, well, x is equal to, now if we put a plus 2 in here, 6 minus 2 times 2 is 2. Or, if we put a negative 2 in there, 6 plus 4 is 10. So our two results should be 2, comma, 2, or negative 2, comma, 10. I think those should be our two results here. Hopefully I've done that right and not stuffed anything up along the way. In fact, I will just quickly check that so I'm not leading you astray into a ditch here. What does 10.2 say? And this is 5b. Yeah, 2, 2, and oh, and I've just got my coordinates around the wrong way because I put the y coordinate first. So it should be the x coordinate first, and we know that the x coordinate is 10. So it's 10 minus 2. Okay, just got my x and y's around the wrong way. Okay, so that's fine. Let's move on to another one. This one here is a word problem, but it's the same kind of thing. We've got a line that cuts a curve at points P and Q, and we've got to find the coordinates of P and Q. Well, I will show you how to do the first part of that. So x plus 2 equals 8 minus x squared. I'm going to bring everything across to the left-hand side. When I bring that 8 across, I'm subtracting it, so it's negative 6 equals to 0. And this looks very familiar. I'm pretty sure we did something like this just before. When I factorize it, I should get that. Let me just quickly check that I've done this all right. X squared plus x minus 6. Yes. Okay, so we get x is equal to minus 3 or 2. Those are the 2 points where it meets. And we need to find y, so we just chuck y. This is going to give us our y. Minus 3 plus 2 is minus 1, and 2 plus 2 is 0. So minus 3 comma minus 1 and 2 comma 0 are the 2 points. And we've got to find the length of PQ. So we go, well, I'll leave you to do that. You're going to use Pythagoras for that. I don't want to waste too much time here. Okay, and this is from exercise 10.3. This is word problems involving simultaneous equations which have quadratics. So here's our rectangle. We don't know what the length or the width is. So we'll call the length x, we'll call this y. And we know that the perimeter is 16.2, which means 2x plus 2y equals 16.2. Or we could divide everything by 2, so it should be 8.1. Okay, and then the area is 16.1, so we go x times y equals 16.1. Alright, I'm going to take this first equation here and rewrite it as y is equal to 8.1 minus x, and now this can be substituted in for y. So let's do that now. X into y, which is 8.1 minus x from our first equation, right? That's the first equation here. And, whoops, I don't know what happened there. It should be equal to 16.1. Let's expand that out. So we get 8.1x minus x squared is equal to 16.1. I'd like to bring everything across to the right-hand side, so I've got a nice positive x squared. And I'll have minus 8.1x. Plus 16.1. Now what I would use at this point is I'm going to use my quadratic formula to find the value of x. X equals minus b, so minus 8.1, plus or minus the square root of negative 8.1, all squared, minus 4 times 1, which is a is 1, right, times c, which is 16.1. And it should be all divided by 2 times a, which is 2 times 1. Now, if we chuck that into our calculator, what value do we get for it? Right, go ahead and try this. Okay, well, I'm getting 23 over 5. Or the other one is 7 over 2. So 3.5 or 4.6. So 4.6 or 3.5, the values for x. Now if you go back here, you can see that actually one of those, if x is the 4.6, then y must be the 3.5 because they add up to 8.1. So those are your two values of the rectangle. Because once you plug them back into this here, you'll see that whatever x is, y must be the other one. Okay, if x is the long one, 4.6, then y must be 3.5, and if x is 3.5, then y must be 4.6. Okay, well I hope that gives you a good wee introduction into this. It's gone a bit long, but hopefully that will help you do some of the questions from the exercise. Keep hitting me up with your questions on the email, and I'll answer them as soon as I can. Alright, God bless guys, take care.